Welcome back to the Best Writing on Mathematics channel. I will give in this video a brief overview of the print edition of the series with a similar name, which I edited for Princeton University Press. In this video, we are speaking about the 2012 edition. In the first article of the selection, Mario Livio ponders the old question of what makes mathematics effective in describing many features of the physical universe, and proposes that its power lies in the peculiar blending between the human ingenuity in inventing flexible and adaptable mathematical tools and the uncanny regularities of the universe. Timothy Gowers brings the perspective of a leading research mathematician to another old question, that concerning features of discovery and elements of invention in mathematics. He discusses some of the psychological aspects of this debate and illustrates it with a wealth of examples. In a succession of short pieces, Peter Rowlett and his colleagues at the British Society for the History of Mathematics present the unexpected applications ricocheting over centuries of notions and results long believed to have no use beyond theoretical mathematics. Brian Hayes puzzles over the proportion between the volume of a sphere and that of the cube circumscribed to it in various dimensions. He offers cogent explanations for the surprising finding that this proportion reaches a maximum in 5 dimensions and it decreases rapidly to insignificant values as the number of dimensions increases. Terence Tao tackles a few conundrums concerning the distribution of prime numbers, noting that the distribution displays elements of order and of chaos, thus challenging simplistic attempts to elucidate its patterns. John Baez and John Huerta tell the story of the tenacious William Hamilton in search of a better number system, and how his invention of the quaternions led John Graves and Arthur Cayley independently to thinking up the octonions, which play a vital role in the theory of strings. David Swart and Bruce Torrance discuss several ways of projecting a sphere on a plane, the qualitative trade-offs involved in them, the basic mathematical underlying such correspondence, and their applications to panoramic photography. Drawing on their experience as mathematicians and choreographers, Sarah Marie Belcastro and Karl Schaffer explore the interplay of dancing and such mathematical ideas as symmetry, group structure, topological links, graphs, and infinity, as well as suggestions of infinity. A musician and mathematician, Rob Schneiderman offers a critical viewpoint on the literature that explores the hidden and the overt connections between music and mathematics, pleading for a deepening of the discourse on their interaction. Robert Lang describes a mathematical condition ensuring that an origami paper folding unfolds into a flat piece of paper. In the second of 2 texts in this volume, Timothy Gowers argues that high school level mathematical thinking of calculus notions is not as different as most professionals assume from the thought process common to similar notions of analysis taught at university courses at a higher level of rigor and abstraction. Brent Davies argues that successful teaching of mathematics relies more on tacit, unconscious skills that support the learner's full engagement with mathematics than on the formal training currently available in preparatory programs for teachers. Erika Flapan tells us with disarming candor about her charming adventures in search of the best methods for teaching mathematics, and concludes that despite various degrees of success, she remains an agnostic in this matter. Bonnie Gold argues that everyone teaching mathematics does it according to certain philosophical assumptions about the nature of mathematics, whether the assumptions are explicit or remain implicit. Susanna Epp examines several uses of the concept of variable in mathematics and opines that from an educational standpoint, the best is to treat variables as placeholders for numbers. David Mumford and Saul Garfunkel plead for a broad reform of the United States system of mathematics education, more attuned to the practical uses of mathematics for the citizenry and less concerned with the high-stakes focus on testing currently undertaken in the United States. Jeremy Gray surveys recent trends in the study of the history of mathematics as compared to research on the history of science and examines the possibility that the two might be somehow integrated in the future. Charlotte Simmons writes about Augustus de Morgan as a mentor of other mathematicians, an aspect less known than the research contributions of the great logician. Giuseppe Bruno, Andrea Genovese, and Gennaro Improta review several formulations of various routing problems with wide applications to matters of mathematical optimization. Special curves were at the forefront of mathematical research about 3 centuries ago, and one of them, the cycloid, attracted the attention and the rivalry of the most famous mathematicians of the time, as Gerald Alexanderson shows in his piece on the Bernoulli family in this volume. Fernando Gouveia examines George Cantor's correspondence to trace the original meaning of Cantor's famous remark, "I see it, but I don't believe it," and to refute the ulterior psychological interpretations that other people have given to this quip. Jan Hacking explains that the enduring fascination of the powerful influence of mathematics on so many Western philosophers lie in the experiences engendered on them by learning and doing mathematics. Richard Elwes delves into the subtleties of mathematical infinity and ventures some speculations on the future clarification of the problems it poses. Finally, in this collection, Mark Collivan illustrates the basic mathematics involved in the games of choice we encounter in life, whenever we face processes that require successive alternative decisions. Besides these pieces, as usual, I included in the volume a list of a list of pieces worthy of consideration that did not make it into the volume. Thank you for watching this video.